So in this video, we're going to look at how the Laplace transform method or the Laplace transform method for solving initial value problems. So the Laplace transform that we learned so far, we're now going to see what's the real point of learning the Laplace transform. One of its major applications is actually solving differential equations using this method. So it all comes from if we move to the table, you will see over here the table of Laplace transforms that the two derivative Laplace transforms. So the first derivative you can see over here, SFS minus F0, and the second derivative you can see here. So S squared Fs minus SF0 and F dash 0. These two over here, okay, these two that you see, this one, this here, and these are initial values. So you can clearly see that this method does not work. It only works for initial value problems, really. Okay, so here you'll see the same for the nth derivative. Again, you'll see all of these are initial values. So they have to be present in the actual problem, and then we can use the Laplace transform to solve it. So let's get into an example. So here's an example, a second order differential equation. We will go to the our table and let's convert. So let's look at the second derivative here. So it's S squared Fs minus SF0. So in this case, it will be XS. So let's work on that. So it's going to be XS over here. Okay, and a second derivative, so it's S squared, sorry. S squared, you can see here. This is what I'm using over here. Okay, so S squared Fs minus S and then X of 0. So X of 0. Okay, and then minus X dash of 0. Okay, so this is now, these are the two values that will be put in here. S squared, okay, so now we'll go to the next term. This is X dash, so we just did X double dash. Now X dash is going to be minus, here you'll see the first derivative, SFS minus, okay, so it'll be S, XS, and plus this time, because of the negative sign, this is minus minus plus, X of 0, and then minus 6 XS, and that's going to be equal to 0. So now we've actually converted the differential equation into the Laplace, transformed it into the Laplace domain, and you will see that there are actually no derivatives left. So now what we're going to do is going to replace these values, okay, with these initial conditions. So we'll have then, so this x0 is 2, so it'll be just minus 2s, minus x dash is this minus 1, so it'll be plus 1, minus, as it is, plus x of 0 is 2, plus x of 0 is 2, minus 6xs equals 0. Now we're going to collect the excess terms and the other terms, so we get this, as you can see here. Okay, and rearranging to get excess alone on the left hand side, we get this result. Now that there are no derivatives left, basically it's time now to go to the inverse Laplace transform. So we need to find the inverse Laplace transform of this. So now we'll find the inverse Laplace transform of this. So x of t is Laplace inverse of this function here. Okay, xs. So therefore we'll just the denominator, as you can see, we'll factor it. This is an example you would have seen before earlier in an earlier video. Now that it's in this form, then we can take the Laplace transform basically of this, the inverse Laplace transform of all of this. But before we do that, we need to write this in partial fractions form. So this is equal to Laplace inverse of basically, so it's Laplace inverse of this after doing the partial fractions, which is equal to 3/5 e to the 3t plus 7/5 e to the minus 2t. And basically that's the solution to this differential equation. So as you can see, very easily applied. It's very simple, easy to apply the Laplace transform method for solving differential equations. Of course, as you can see that it is a method for initial value problems only. It has that limitation. So that's it. We'll stop here. Thank you so much.